Number 12, factor the second degree trinomial 1x squared plus 2x minus 27, starting with the greatest common factor, which is 1. Since it's a second degree trinomial, we try to factor it as a product of two binomials. First term is x, and then we look at the constant 27 and think of the pairs of factors of 27, 1 times 27, 3 times 9. Now we cannot add the two numbers from either pair or subtract the two numbers from either pair to get to the middle coefficient. So this trinomial is a prime polynomial and cannot be factored, so we strike a line through it or erase it completely and write prime polynomial, which means cannot be factored. Number 13, second degree trinomial. There is a common factor, greatest common factor of 2. We'll factor that out, times x squared plus 6x minus 27. So inside the parentheses, we have a second degree trinomial again. So we'll try to factor it as a product of two binomials. Now 27 has the pair of factors 3 and 9, which has a difference of 6 if we do a 9 minus 3. So let's do 9 times 3. And for plus 6x as a middle term, we need a plus with the 9 and minus with the 3, because when you FOIL, multiply, if your outer product is 3 times x and your inner product is 9 times x, and we must obtain plus 6x as the middle term, we need plus 9x, so plus with 9, subtract 3, so minus with 3, and now both binomials are prime. Their greatest common factor is 1. So we factored completely. We also get minus 27 when we multiply. Number 14. Now, notice we have perfect squares first term, and the third term are perfect squares and second degree trinomials. So this looks like perfect square a squared. The middle term contains a 2. So the formula we're going to use is for a squared plus 2 times a times b. And 81 is 9 squared. So in our formula, it's b squared. Now we could think of this as the square of 5a quantity squared. And 81 is 9 squared. Therefore, 5 little a is capital A, and 9 is capital B. So the middle term, to verify that we have a perfect square trinomial, a PST, perfect square trinomial. We'll check the middle term is 2 from the formula, 2ab, times capital A, which is 5 times little a, times b, which is 9. So in the middle, 2 times 5 is 10, times 9 is 90, a. So this confirms we have an expression, a trinomial that fits the special pattern for a perfect square trinomial and thus is factorable. So as a product of two binomials, the first term is capital A, which is 5 little a. And the second term is B, which is 9. Addition everywhere. And to check it, The outer product is 45a. The inner product is 45a, which add up to 90a, so checks out. And this is the same as the square of the sum 5a plus 9 quantity squared. Number 15. Now note that the first term is a perfect square. The square of 4y, and 9 is the square of 3. The middle term has a minus, so that reminds us of the formula having minus 2 as a factor. And the formula for the perfect square trinomial with the minus is a squared minus 2 times a times b plus b squared. Therefore, capital A is 4y, and b is 3. Now the middle term, to confirm we have a perfect square trinomial, we'll take from the formula minus 2 times a, which is 4y, times b, which is 3. So multiplying 2 times 4 is 8, 8 times 3 is 24, times y, that's the middle term. So we do have a perfect square trinomial, and it will factor as a product of two binomials. First term, 4y. Second term, 3. And since the middle term has a minus, it'll be minus minus. And we can verify that by multiplying. Check that we get minus 24y. And this product is the same as the square of the difference, 4y minus 3 quantity squared. 16. So we have a binomial. We observe two squares, p squared, q squared, and a greatest common factor that we can factor out is 2. So let's start by factoring out the 2 times 4p squared minus 9q squared. So still, we have two squares, p squared, q squared, but also 4 is a perfect square, 9 is a perfect square. So we can think of this, we can rewrite it as, let's put a bracket here, 2p quantity squared minus 3q quantity squared, close bracket. And then we have inside the brackets what looks like capital A squared minus capital B squared, a difference of two squares, which factors as a product of conjugates, a plus b, a minus b. So this will equal GCF2 times the product of conjugates, 2p times 2p would be 4p squared, and 3q times 3q will be 9q squared. Conjugates have opposite signs. Conjugates are two binomials with opposite signs. One's a plus, the other's a minus, or vice versa, first minus and then plus. Number 17. We have a binomial sum, and the clue, the exponent of 3 tells us perfect cube, which leads us to the question, is 64 a perfect cube? And we can figure it out that 64 is 4 times 4 times 4, or 4 cubed. So this reminds us to use the factoring formula for the sum of two cubes, a cubed plus b cubed, where Capital A is X, and B is 4. So the factoring formula for the sum of cubes, let's write it underneath. Since it's a sum, it starts off with a binomial sum times a trinomial, a squared, then opposite sign, minus a times b plus b squared. So everywhere there's an a, we'll substitute x. Everywhere there's a b, substitute 4. So we have x plus 4. A squared will be x squared minus a is x and b is 4. So x times 4, which is the same as 4 times x. And b squared will be 4 squared, which is 16. Number 18. We have a binomial and a clue, the exponent of 3. So y cubed is a perfect cube, and the greatest common factor, which is always the first step, is 3. We can factor out 3. So 3 times a perfect cube minus 8. And 8 is a perfect cube. So we have a difference of 2 cubes. So we can think of that as y cubed minus 2 cubed. And then use the factoring formula for the difference of 2 cubes. A cubed minus b cubed, where a is y and b is 2. So let's put the formula over here, which will be, since it's a difference by a binomial difference or difference of 2 cubes, the first sign will be a minus and a binomial a minus b. Then the next sign is opposite, so it'll be a plus, a squared plus a times b plus b squared. So keeping the GCF of 3 and substituting anywhere there's an a, replace it with y and substitute for b 2. So we have y minus 2 times y squared plus, now ab will be y times 2, which is the same as 2 times y, and b squared will be 2 squared, which is 4, so plus 4. Number 19, factor the second degree trinomial. The greatest common factor is 1. So let's try to factor this as the product of 2 binomials. Okay, so let's put down the 2 binomials. This is kind of our structure. 20 could be factored as 1 times 20, 2 times 10, 4 times 5. So let's try 4 times 5 first. 4y times 5y is 20y squared. And 18 would be 1 and 18, 2 times 9, 9 times 2, and order does matter because the leading coefficient is not a 1. The leading coefficient is 20, so switching the order of these constants will make a difference. And we have 3 times 6 and 6 times 3. Now, if there's many choices, many possibilities, some of them we can eliminate if the greatest common factor is 1. So that means when we factor 18, we cannot have, for example, 2 times 9, because then there would be a common factor of 2 with 4y and 2. That would be a contradiction because the greatest common factor is 1, so it cannot be 2. Can't switch to a 2. The symbol for contradiction is a circle with an inscribed X. That means contradiction, so that can't be. So we're going to put a line and strike 2 times 9, and then erase to a 9. The same reason the factorization cannot be, for 18, cannot be 6 times 3, because then 4 and 6 would have a common factor of 2. So we'll strike that one out and erase 6 and 3. So it could be 9 and 2, but 9 would give us a rather large product. Not that that's always wrong, but 9 times 5 is 45, and 4 times 2 is 8, but the middle coefficient is 9, minus 9, so that's not going to work. So we're last with 3 times 6. So let's check the inner product and outer product. The outer product, O, is 24y. The inner product is 15y. And we must get minus 9y as the middle term. So that means we need a minus 24 and a plus 15 to get minus 9. Therefore, we need a minus with the 6 and a plus with the 3. And verify we also get minus 18. So everything checks out. Number 20 is a binomial with a leading coefficient that is negative and the greatest common factor, which by definition is a positive quantity. Greatest common factor is 5. So we're going to factor out a negative with the GCF. In other words, factor out negative 5 times a squared, and the negative times a minus. And 5 divides 80 16 times. So we have now inside the parentheses a difference of 2 squares, like a squared minus b squared, where capital A in the formula would be little a, and b would be 4, since 4 squared is 16. So we'll factor the difference of 2 squares as the product of conjugates. So think of a plus b times a minus b. So we have first term, little a, second term, 4. One binomial has a plus and the other one has a minus. 21. 2 terms. We want to look for the greatest common factor, always as the first step. We can factor out 3. R is common, and the least exponent is a 2. And S is not common. So we can factor out 3r squared and multiply that by r cubed. Exponents 2 and 3 add to 5, minus 8s cubed. Inside the parentheses, we have a binomial difference, and the exponents of 3 are clues that we have cubes and a difference of 2 cubes. Therefore, we're going to use the difference of 2 cubes factoring formula. Now we could rewrite 8s cubed as the cube of 2s. Also, let's use a bracket here. So we have r cubed. And I put in bracket because I'm going to introduce parentheses here around the 2 times s quantity cube will give 8s cubed, close bracket. So the factoring formula for the difference of cubes is a cubed minus b cubed. Therefore, capital A will be r, and b will be 2s. So the formula, keeping the GCF, is, since it's a difference of cubes, it's going to be a minus b, same sign, minus minus, then a squared, opposite sign, plus a times b plus b squared. So everywhere there's an a, substitute r, and everywhere there's a b, replace with 2s. So we have r minus 2 times s. A squared will be r squared plus ab will be r times 2s. R2s is the same as 2rs, coefficient first, and then b squared will be the square of 2 times s, and 2s quantity squared is 4s squared.